Okay, hi guys. Let's just try to solve some few questions nyana, ne? It's Mbaba from Tutor First, ne? We do everything maths and science. So I was just given someone to do some things here. So I'm seeing that let's just try to solve this issue. I'm seeing or I'm picking up certain patterns in in a sense of factorizing. So if you encounter a situation like this one, you need to do the following things. You can either use the quadratic formula, or you can use the method which I have taught you. You can use p 2p squared minus 2p minus a 12. So now you look at the factors. Let me just change the marker here, maybe so that you can see. You need to find factors which, when you multiply them together, they give you 2p squared. So in this case, you'll just have 2p and also a 1 what and 1p. You need to find factors which, when you multiply them together, they give you a 12. So you are having 12 multiplied by 1, 4 multiplied by 3. So the one which is suitable here, it's most probably what? It's most probably a 4 and a 3. So you place your 3 here and then your 4 here. So also it depends how you place the 4 and also the 3. Let's take for an example, I place them like this, né? Because you need to cross multiply now. So cross multiplying, you'll see that you get 1 multiplied by 1p multiplied by 4, you just get a 4p. And then 2 multiplied by 6 by 3, you just get a 6p. Do you see that this answer which is here, it's saying negative 2. So it means the 4 needs to be a positive and the 3 needs to be a negative. So in this case, you get a negative 6 here. And then when you add the two things, you'll just get a negative 2. So vice versa, I would have written maybe, let's say, a 3 here. Let's say I'd written a 3. Let me just rub. I want to show you all the possible answers. So which one, and also which one is right and which one is wrong. If I place a 3 here and I place a 4 here, do you see that I will say 2 multiplied by 4, it just gives me an 8, and then 1 multiplied by 3, it just gives me a 3. Even though if I can place 4 as a negative, it will give me negative 8 here. Still, when I add the two, they will just give me what? A negative 5, which in this case is not what we need. So it means the suitable situation is this one. So it means this here will be your, what do you call this thing? This will be your factors. So in this case, you will just have 2p and then plus a 4, close bracket, and then 1p minus 3, and then as your factors. So you will just end here. This is for 1.1.3. So that's it. I hope you understood this. Let me just place it here. And then let's come to 1.2.1, 1.2.1. For 1.2.1, this is more of exponents. So you will say 2 to the power of a plus 1 minus 2 to the power of a minus 1 divided by 2 to the power of a. So when you've got a situation like this one, you need to remember exponential laws. So you have got a maybe to the power of n plus 1, which is the same as a to the power of n multiplied by a to the power of 1. So if you're having a to the power of n divided by a to the power of 1, maybe this is the same as a to the power of n minus 1 when you're dividing them. I hope you are understanding what I'm saying. Let me just keep this thing here for a reference sake, and then let's proceed now. Proceeding, I'll then write the 2 into, or divide it into its individual forms, like this: minus 2 to the power of a, and also 2 to the power of minus 1, and then all divided by 2 to the power of a. Do you see that there's more like a common factor here on top? And the common factor here is just the 2 to the power of a, and also 2 to the power of a, sorry, it means I will remove it as a common factor and then say 2 to the power of 1 minus a 2 to the power of negative 1 close bracket, and all divided by 2 to the power of a. Do you see that the 2 to the power of a and 2 to the power of a cancel each other, and then you just be left with 2 minus 2 to the power of negative 1. So when you have something like this, it's just 2 minus 2 to the power of negative 1 over this, which is just 2 minus 1 over a 2, which will just give you an answer of 3 over a 2. I hope you understand this well. Then let me try to place it here. If you don't understand, just try to comment on my um, what do you call this thing on the video, and then I'll get back to you. And then let's come to this part again. You've got x, which is 1.2.2, and then you've got x squared minus x plus 1 divided by x to the power of 3 plus a 1. So when you have this, and then it's dividing here, sorry, 2x all divided by 2 to the power 2x then plus 2. So if you're, for instance, if you're having a situation like this one, I would say that remember whatever you were doing here in 1.1.1, wherein you were factorizing by removing the common factor, or this which you were doing here in 1.1.3. So you need to follow the same what plan or procedure. So it means now when it comes to the x squared minus x plus 1, it means I would say that just keep it the way it is, because if you try to factorize this, there are no factors. So we'll just say x squared minus x plus a 1, and then underneath you are having, what do you call this? Underneath you are having x squared plus 3, which is a cube this. So here you will come here and then write 1/3 of it. You will factorize this. So it will be something like this. And then x squared minus multiply 1 and then x, it will just give you x, and then plus a 1 here. So you have factorized this part. Then you change this to a multiplication. When you change it, it forces this to reciprocate. So you'll have 2x plus 2 all divided by 2x. Now, do you see that you do have things which can cancel? You've got this which will cancel with this, which will be left with 1 over x plus a 1, and then multiplied by remove. Okay, this is the multiplication. Remove 2 as a common factor here. You'll say 2 into an x plus a 1 all divided by 2x. Now cancel the 2 and 2, then also cancel this x plus 1 and also x plus 1. Actually, you're just left with 1 over x. I hope you get that. And then let's move on to 2 point what? 2.3. So for 2.3, you are having the following things. 2.3, so it's 2.3.1. Then they say calculate the value of 2x plus y. You are being given a situation like this one. So I would say that because they are saying 2x plus y, I would say focus on what you are having here, which is 4xy squared minus that. So in doing that, it means you write 4x squared minus, I would say y squared, and then let me check. Okay, equals to, let me check if 171 is a square root of something. 171, if 171 is a square root of if something, so or let me leave it the way it is. Let me not do it now. 1 7. Okay, let's try to factorize this. This is just going to be this is a difference of two squares, mind you. This is 2x minus y, and then you have got 2x plus y, and then this will just give you 171. I'm trying to check if there is a square root of what do you call this, 171. Okay, but there isn't. Now let's look at what is given here. We are given that 2x minus y is a 9. So it means where there is a 2x minus y, let's replace with a 9 into a 2x plus a y equals to 171. So let's divide the 171 with a 9 and see what we get. So dividing both sides with a 9, dividing both sides with a 9, let us see. You'll have 2x plus y equals to a 19. Then from there, 2x plus y, do you see this 2x plus y? It's this one which is here. It means our 2x plus y is just going to be equals to a 19. I hope you understand. And then now they say solve what? Solve x and y simultaneously. So from there, let me just keep this and place it, yeah, for your reference. So what we got now, we got that 2xy plus, this is 2.3.2. So we got that 2x plus y is the same as 19, and we already know there that we have got 2 x, what do you call this thing, minus y equals to a 9. So it means now, by the look of things, I can use that method of making the subject of the formula something. So I'll choose to make y the subject of the formula, and I'll choose it on equation 2. So I'll say from equation what? From equation 2, I make y the subject of the formula, which will just give me 2x minus a 9. So I'll then say this is still equation 2, ne? I'll say substitute equation number 2 into equation number 1. So it means wherever there is a y, I'll place 2x minus a 9. So I'll say 2x plus, where there is a y, I'm going to place a, let me write it with a different color so you can see. It will be a 2x minus a 9, close bracket, equals to a 19 now. And then I'll then say 2x plus 2x minus 9 equals to a 19. So 2 plus 2 will just give me what? 4x. And then from there, I will then have, take the 9 to the other side. I will have, it will give me 28, I'm sure. It will be 19 plus 9, which will just give me what? 28. So 28 divided by 4, it will just be 4 here, and then x equals to a 7. Then from here now, I can go back and substitute for, what do you call this, for y. So for y, I'll say y, sorry, I'll say, my pen just went offline. Okay, I'll then go back and substitute in the equation number 2, and then where there is an x, I will place a 7. So in doing so, yeah, it's back now. So it means I'll have y equals to, I'm substituting in this equation now, y equals to 2, where there's this x, I'll place a 7 minus a 9. So now it's more like a 14, 4, 14 minus a 9. So 14 minus 9, how much do I get? So minus 14, I'm sure you get a 5, né? 14 minus a 9, you just get what? A 5. And then that's it. I hope you understand, or you understood.